Good afternoon, everyone. Just a couple minutes before 1 p.m. Eastern, and we'll get started shortly. Just waiting for everyone to start rolling in, and then we'll get going. So just hang tight, and we'll get started shortly. Thanks. Hey everyone, for those rolling in right now, we're going to hang tight for one more minute and wait for a few more people to join, and then we will jump into the content. So we'll get started in just 1 second. Thanks. Okay, so it's right around 1 p.m. Eastern, so we'll just get started. A few more people are rolling in, but excited to see the turnout for today. But we'll get started. Hi everyone, welcome to Traffic Link User Training. This is part one of a series that is going to be rolling out over the coming months, and we're going to be providing some great content along the way. Today is about working with video detection and our continuous count product. This is a follow-up to a series of webinars that we've been doing talking about the feature and functionality that this product brings, and now today we're going to get into the meat of it and really start diving into the how part. Exactly how does this work? So again, welcome. This is the start of a great program. We're excited to take you through a rotating series of topics. Today, like I said, is around detection and counts. Next round will be signal management, and then we'll work into intersection metrics and clear signals and so on. So look out for a series of these over the coming months. We'll do about one a month to make sure that we're providing as much knowledge share opportunities as possible. Many of our partners and customers are on the call today, which is very exciting to see. So I hope we deliver quite a bit of useful information here. So we have a pretty packed agenda, and just to kind of introduce myself, my name is Brent Rogerson. I've probably worked with many of you on this call, and we've done intersections together. We've done training sessions before in the past. So I'll kick off this session today, which is really exciting. So I'll take you through one more. Today's agenda, like I said, is a little bit packed, so we'll cover quite a bit of topics. We do have quite a bit of ground to cover, so I'll keep moving, but we'll go over just a system recap. We're not going to get too much into the hardware and cabinet side. We're going to focus more on the platform and software part today. We're going to go through some helpful concepts, basic intersection operations, some terminology that I'll be using and why it's important to how we configure our devices and how we leverage detection and counts. From there, we'll jump right into the platform. We're going to do a configuration together. We're going to talk through some of the presence detection and some of the count detection that we're going to be doing and how it's actually set up and some tools along the way. So like I said, there is quite a bit of content. So if you have questions, please chat us in the webinar chat window. I'll try to save 10 minutes at the end to answer some common ones that I see in it. Otherwise, we'll follow up with you directly at the end. If you want more than that, or if you want a one-on-one session, feel free to email our support team or contact your local distributor that that you're familiar with that has Miovision products or Miovision sales or our support teams. Many of you know our technical account managers as well. So feel free to reach out to us, and we'll cover and do as many sessions as you would like. So don't hesitate to ask. I'll try to save some good time at the end to cover that. So let's get into it. Just as a recap before we get over to the software, just as a reminder, just as some context behind what hardware is driving a lot of this at the cabinet, we have our Miovision devices in the cabinet that go up to the web-based portal. So we have our SmartLink, which is generally our 4G LTE modem. A lot of our data and communications is transferred through here. So it's our hub of information. The next one is our Smart Sense, so the detection processor there in the middle. This is the brains of the operations. It's doing the local processing. It's our graphic processor units at the side of the road. It's what we're going to be configuring today, which connects from our SmartView camera. So this is the more obvious one. It's a camera on top of a signal pole. It's 360 degrees, and it allows us to get eyes on the entire intersection. All of this is managed and viewed through our TrafficLink web portal. So we're going to spend most of our time in the portal today. I do recognize that there's probably questions about the hardware and integrations into cabinets. So maybe based on some feedback, if we get at the following this, that maybe a nice follow-up session to this would be the hardware and cabinet integration side. But for today, we'll focus on the software components. So quick architecture view, just to put it together. We have our camera up on the traffic signal pole that can either be on the upright part or out on a mast arm. The name of the game is to get the camera to the most logical spot that gets us the best view of the intersection. The view of the intersection is really important to our ability to detect and count. It also has implications to how many cameras we may need depending on size of intersections and whatnot. So working with the teams to make sure you're getting the right coverage is important. Installing those devices, the SmartLink and SmartView, into the cabinet itself with their antenna on the top of the cabinet, then transmits everything back to our TrafficLink platform, where we can operate and manage our intersections remotely using TrafficLink. And you see a quick little image there of an intersection view. So that's our TrafficLink platform. So this is kind of a top to bottom view of what the operation is and what visibility we generally get into an intersection. So let's set one up. One of the questions I had about the audience that I wanted to just kind of wrap my head around a little bit leading into this training is I kind of want to get a sense of who's in the audience, or more specifically this question here: are you actually responsible for detection configurations? We are going to post a poll for you to answer. If you can go ahead and respond to that, that'd be really helpful to get an idea of who's actually responsible for configurations, or if you're just here listening to see what it's all about. I'll give you a second to answer that. Great, that looks like it is posting there. Oh, I don't actually see them.
Hey Brent, it's Shannon here. So sorry if you can't see that. Hopefully everybody else can see it, but as the results came in, we've got 65% that say that they are responsible for detection configurations, and the remaining 35% says no.
Okay, great, thank you. That's great, thanks for that. As a follow-up to that question, it would be really good to get an understanding of your experience level with the detection configuration. Are you just a beginner, just getting started? Are you starting to wrap your head around it? Are you actually claiming you're an expert? If you are, I'd love to see that. And then get into then maybe a couple other options there. So let me know what your experience level is, and then that'll help me maybe phrase or provide a better experience in this session here. So Shannon, if you want to post that again.
You bet, it's up there and I see the answers coming in, so we'll just give it a few more seconds. Okay, so we've got 44% Brent are beginner, 33 are getting there, and then expert or other share about 10% each.
Okay, great. That's great. Great to hear.
Yeah.
Awesome. Good to hear. We have some experts in the group and good range of skill set there. So sounds good. Let's get into it and see how I can help you understand and help you learn how to continuously build on this knowledge. So one of the main concepts that I needed to start learning when I first started configuring intersections is really wrap my head around intersection design and the operational concepts that kind of make up the basis of detection and then make up the basis of actuation. So how do we actually input information to a traffic controller? I mean, at the core of it, a detection zone is saying there's an object here waiting at the intersection, but how do all the pieces connect and what terminology am I going to be really using along the way? So I'm going to cover some quick helpful concepts around intersection phase design, channel assignments. I'm going to talk a little bit about presence mode and what that means, pedestrian counts, turning movement counts, and a new feature we just released a couple weeks ago called the turning movement heat map validations, which is a really fun feature to show off. So I'm going to get into that a little bit today. So to kind of get into it, the phase design is such an important piece of detection configuration. This is the biggest concept to really understand first before we start connecting some of the dots. Many of this is likely kind of detection 101 or intersection 101 for many of you, but I want to make sure we're using the right words, or when I say phases or those types of things, it makes sense to you. So phasing of an intersection is representative of a movement at an intersection. So this is a very typical intersection design here. You see the phase numbering. So left turns are odd numbers, through movements, and right turns are even numbers. This is a very basic intersection design. Obviously, there's some more complex ones with right turn phases, or there's multiple versions of left turn advances and things like that. So at a very basic intersection, we have this phase design. In addition to the phase design, there's the pedestrian phases that tell you when you can walk and cross the road and whatnot. So often when I'm asking someone when we're configuring an intersection, this is usually where I start. What is the phase design? Is there a document, or is there a way to help me understand if I say phase 3 left turn, which direction is that? So there's an obvious association of a movement to a phase to a detector zone. So if you think about that, a detector zone calls a phase. Phase is for a particular movement at the intersection, and we're just basically connecting the dots there. So some 101 information there. And if you, in some ways, I like to think about it as the 7-11 rule. Minors add up to 11, 3 and 8, 4 and 7. Those add up to 11. 2 and 5 are 7, 1 and 6 are 7. So interesting way to wrap your head around it. But so basically what we're trying to do here is first understand the intersection, and every intersection is slightly different. That's why we have to ask, or that's why it should be your starting point when you're talking about configuration. Often we're drawing a detector zone, call it the phase 3 left turn or phase 7 left turn. There's a detection zone associated with that phase. And when we link them together, we say on detector zone 3, it calls phase 3. And that's a very common design, is that phase and channel numbers are equal, but they don't have to be. And so sometimes when you get into more complex intersections, that statement changes. So we usually have to level set on what is the vehicle zone to phase association that we're working with. That means what phasing is what direction, and we're basically trying to line up the northbound left equals phase 1 detector channel 1. And so we're lining up that association and making sure the controller is actually configured to accept this, so that when we plug in our devices to the traffic controller and we start saying that, hey, there's a car waiting on channel 1, the controller knows how to make sense of that and know what to do with that. So this is a quick little image of what it looks like on the actual controller itself, where you can line up a detector channel number with a phase number, and you can make that association. And they can be as complex or as simple as you want them to be. This is for you as a customer to design. We just need to make sure that they're associated in a way that makes sense. So this is often part of the checklist when it comes to intersection configuration, talking about what is the phase design, what is the vehicle to phase association, so that we can, when we configure it, we're staying in that mindset the whole way through. So keep that in mind as we get into the platform side. Presence detection. So I'll be saying words like presence detection or stop bar detection. These are the zones that are at the stop bar or at the front of the intersection where cars come in and wait. So maybe an obvious statement, but presence detection is what the core of this is. And we draw zones that look like this. They often are the box or the zone that places the call to the controller. So their design is also equally important. So thinking about how far back do I need to go? How short should they be? Every customer that I have talked with actually has a different answer to that. There are standardization plans that many cities and agencies have adopted, but it's really for you as the user to define. If you have a zone that's really long, that means that the presence will be held longer, or the gaps between vehicles will hold the calls longer if you're doing things like extensions based on volume. So the more cars that are coming, the longer the phase holds, and then eventually it'll gap out because the time between detector hits becomes too large. So getting these zones, understanding how you want your intersection to operate, how you want the phasing to accept the detectors, are all a foundational layer of designing it in the traffic link portal properly. So from a technical support side, often when I'm talking with a customer calls me from the road side, like, hey, can you help me get this set up? These are the questions I start with. What is the phasing? What are the detector associations? And what is our general concept of zones? And let's get it right. So that the expectation or the outcome at the intersection is what you actually expect it to be. We're going to talk a little bit about counts. And so one of the counts is pedestrian. So this is another type of zone that we're going to get into in the configuration side, the crosswalk zone. This is a crosswalk zone that actually provides bidirectional pedestrian counts. So it'll tell you how many and which way are they going at all approaches. And this is actually configured at the same time as drawing the detector zones. So we're going to kind of do this step at the same time in the platform. It also lets us measure for things like pedestrian occupancy for charts that we have on the performance and safety side called compliance. So not only are we counting them and the direction they're going, but also understanding where are they and when are they to help build some of those safety metrics on the other side of our platform. Not all of the data points may be relevant to detection specifically, but in the configuration process, it's important to make note of some of the things we could set up. So crosswalk detection. Turning movement count configuration would be our last step where we actually finish this quick demo together. It's a typical configuration that we do and we think about for the last 15 years or so, considering the Scout side of our business as well as the permanent part of our installations here. But this is a typical intersection configuration that we will get into. It has all 16 typical movements, so that's your through, left, right, and U-turns. So making sure we're accounting for each one of them as we need to. Not all intersections permit U-turns, so you get to decide if you want to keep that or not. I've been in some scenarios where we've caught some interesting data points off the U-turns where cars were doing things or trucks were doing things that we didn't quite expect them to be doing, and they were caught in the data. You'll also notice that we're doing tracks by lane. So for the through movement here, the through northbound through 1 and northbound through 2 are actually drawn separately in the configuration. This is very important to our count accuracy and our movement assignment. So making sure that we're we're really following where the tracks of the cars are and making sure they're being associated with the right movements. That way, the count accuracy is just as accurate as what we could do for actuation. And so those are two different things. So an actuation zone, so looking at our presence detector again, these are placing a call to the controller saying that there is a vehicle here waiting. That is a different concept. So that is actually looking at placing a call to the controller so that it will actuate for them or will optimize based on cars waiting. The turning movement count is a separate configuration because we're not necessarily caring about if there's something there, it's how many or something there. So we are doing the turning movement counts separately and we're tracking them by movement from start to finish. Whereas a zone, you don't actually care or need to care where they end. Whereas an account, we need to know where they end to be able to include them in data. So the zones, or for the tracks for the count, are just as important here to make sure that we get them into a logical spot and we draw them accordingly. Even though we do by lane configurations, and you'll see this as I'm getting through it in the platform, the data is still combined at the end. So that means northbound through 1 and northbound through 2 will only be presented in the data as northbound through. This is to help you just look at the total numbers, not necessarily the granular data sets, but that data by lane is available in our API data set. So you can get access to it if you're doing lane-based analysis or things like that. Another point on why the lane is important is somewhat building up towards our compliance metrics again on the safety side. If you say purchase the performance modules alongside your detection tools here, the lane is actually, or this line, those orange tracks that you see, is actually where the compliance data comes from, or the position of a vehicle in relation to the movement they're taking for some of those compliance metrics, notably the one called red light runner. So if you're utilizing or taking advantage of the performance measures, these add quite a bit of benefit to the accuracy of those charts. So as a standard process, just make sure you configure them as much as possible. But as I was saying that, I was putting some emphasis on getting the tracks right, but it's actually kind of hard sometimes just looking at a 360 image of where do cars actually travel. And so we recently launched the turning movement configuration heat map, which I've been finding an incredibly helpful tool to getting our tracks in the right spot. This is available 24 hours after you configure a turning movement count. And I'll show you where you can find that once we get into the platform side. And where it becomes available, but it actually tells you the history of car tracks. It tells you where cars have been, where the movements are, and allows you to adjust your lanes accordingly. This is actually our step one into what we're calling the basis of auto configuration. So if you can imagine a world where it just observed the intersection and then auto configured around what it's observing, that would be an incredible feature. And this is step one into progressing towards that. So as a first step, you're getting some feedback on, did I draw my lines where I should have? Am I getting the most accuracy that I could be getting? And this tool really helps you get there. So it's available 24 hours after you've configured, and then you can make an adjustment. Sometimes it's hard to understand the projection of a car on the road by looking at like a 2D screen or just looking at your monitor. It's hard to necessarily tell exactly where the cars are traveling or how they're projected onto the road. And so this really gives you an answer to that question and allows you to adjust the turning movement counts accordingly. It also helps you understand where maybe you didn't expect data to be happening, like if there was a bike lane or if there was more than one natural path for a car to follow. You'll see it in the heat map exactly where cars follow specifically. So it's a handy tool to make sure that our configurations are actually progressing the way we want them to. All right. Great. So let's get into it. Let's actually go look at a configuration. So I'm going to do a configuration at this intersection here. Just a quick disclaimer, this is a safe environment. I'm not actually doing anything on a live intersection. That would be not the greatest thing to do in front of a large group. So we're using a safe environment at an intersection that is not connected here so that I could, for the purposes of this, we can demo it. So when we are connected, and we are starting to set up our detection, the first spot is we have to actually start with the detection devices or devices at an intersection. And so what that means is I often start at the device page looking at, first we have a controller. So how are we connected to the controller? Are we reading back from the controller any information? And in some cases, we can set up remote access to the controller so that you can do some of your configurations remotely on the controller side. The same you can do remotely on our tools. So getting a connection to the controller is pretty helpful for that reason. Not always necessary. It's more necessary for the performance measure side. And more on the detection side, it's about remote access to it to make sure that you can manage the configurations. Then obviously we have our smart links, our smart sends, and our smart view, and you can add these devices by adding new. Often this is where our technical account managers help. This is where we can help make sure you have the right devices. Our partners spend a lot of time making sure that we're managing the inventory out to intersections as well. So getting this sorted out is almost just as important as the intersection phase design. So how does the intersection operate and what devices do you have is kind of the basis of this. Once we get that sorted out, or we understand the foundational components there and we have the devices added to an intersection, we can get right into the configuration. This is where the fun begins. So I'll go down to the next tab, the bottom one here, the configuration. And so a few things pop up, and it covers some of the topics I was just saying before. So signal design, so what is phase 2? How are we labeling it? What approach is it associated with? And you can see this is very data table design, because we're trying to make those associations. When we add a detector channel, which is over here on the detector side, when we're saying detector channels, what does that actually mean? What channel numbers are associated with which movements? And so that table of information is often the starting point so that we can make sense of it. And this also is the foundational parts of the data. So signals and detectors are on the left side here. You'll also notice the number of channels. And so actually one piece that I missed over on the device side, I'll just quickly cover that before I get right into the configuration. If I edit on my smart sends, so many cabinets that we integrate with are your standard TS2 design. So those are the SDLC type of cabinets and controllers. That SDLC integration allows us to utilize up to 64 detector channels. You can have different versions. So we have, many of you probably don't know, but we used to have an ABC integration device that we don't use as much anymore because most cabinets are SDLC at this point. But we do have things like ABC boxes, but they really only let you use 16 channels. We also have a wiring harness, which is what we call GPIO. The wiring harness only allows us to use up to 16 channels as well. That's why we like SDLC. SDLC gives us up to 64 different channels. And in the future with the ATC cabinets, we can even start stretching that to 128. So this definitely is the right way to get the most number of channels. But you can also see that on the channels, we have them broken down into blocks of 16. The purpose of this is actually on the controller side. They're called detector rack 1, 2, 3, and 4. A device can be assigned to one of those detector racks, or it can be assigned to all 4 of them. So effectively, our device acts as a detector rack in the cabinet. You can say it's detector rack 1, 2, 3, or 4, and be on all channels, or just a subset. And the only purpose that you do a subset of channels would be, say, there's another technology in the cabinet that's actually using channels as well. And that could be, say, upstream loops for dilemma detection, or it could mean another type of detector system utilizing, say, channels 1 through 16, and you would feel more comfortable with us associating our detector zones on higher channels. So this really lets you control what detector channels we're talking about and how to associate them to a phase call. And so I often use the phrasing phase call, which is we assign a zone to a channel and the channel calls a phase, saying there's a car waiting here. So you have full control over what channels and what type of configuration that you're doing. You'll notice this little enable actuation button that is off at the moment. That's because we're not actually sending anything to this traffic controller. We're running in a demo environment here, so it's kind of safe. Nothing's actuating here, but you actually have full control of actuation as well. You can have it fully up and running and configured and just running parallel to everything in the cabinet. That way you can build data sets, or you can test out the product and see how well it's going. And then when you're comfortable, turn on actuation and then we start sending detector calls to the controller. So this gives you a little bit more of a level of control on how you want to roll out a device or how you want to evaluate a device if you're at that phase. So let's go over to the configuration page again. So up at the top right, you'll see that there is some intersection details. This is really around looking at our device. So we have our smart link here. We're saying this one is installed. You can shut off globally the alerts for this intersection if you want, or you can just keep notes for yourself if you want to as well. In the event of a device replacement, this is actually where we actually go in and change a device for the smart link side, as well as that device page. So it gives you some intersection details that are helpful. And then we have our configure smart sense. So let's click on that. So now we get into the smart sense configuration, which you can see already that I have one up and running and configured here. So I've already done this once, so I'm going to redo kind of what I had here so that we can really look at what was done. But before I get into creating a new configuration, I just want to call out the history versus the deployed configuration. When we have a deployed one, you can obviously see that you can see what's configured and what's out there, and you get kind of a current snapshot of what it looks like. But you also get the history of the intersection. In the history of the intersection, it allows you to toggle between prior configurations, or say there was a construction scenario where you temporarily needed to move some zones and then you move them back at the end of the day once, say, barrel cones are moved or whatever it may be. This saves every revision of configuration, which allows you to toggle through in a much better way. It also lets you have an audit trail on who's changing your configurations, which is an important thing if you have more than yourself in there changing configurations. You want to be able to point to who touched it last. This is a common practice in many traffic cabinets, and I often see it in the form of logbooks or controller passwords, whatever it may be. Logging with audit trails is important, especially if something not ideal is actually occurring and you want to figure out why is that occurring or who started that and how do we finish it. So anyways, that history is captured in a way that you can really keep an eye on it, and you can see when it was last changed. So this one I was playing around with a little bit earlier today. So it says I deployed it around 8:39 this morning, which is great. But anyways, let's configure a new one. Let's just start from scratch. So we'll create a new one. All right, so the first step is we get an image of the camera. We can see a little bit of the layout on the left of the camera, and you'll notice almost immediately that the quality of this image is much higher. If you're familiar with our video stream, we purposely degrade the video stream for the purposes of SEL for the most part, but it also comes with great attributes like minimizing personal identifiable information, or it just blurs it enough that you know it can't be used for those types of scenarios. It is specifically used for traffic monitoring and so on. But in terms of configuring it, having the higher quality image really helps us draw the zones the best way possible. The device locally at the cabinet will see it. Will see the video stream in the highest quality possible, the 4K version. So configuring on the 4K version will help us get it as accurate as possible. So there's 3 steps to the configuration. The first one is the camera configuration. That is talking about where is the camera, which direction is it facing, and how high is it up. This gives our algorithms and our models a starting point. So this really tells us where is it and how to get it to be as most accurate right out of the box as possible. Eventually, this can be automated. A lot of this can be automated, similar to how we did the turning movement count thing that I showed you a minute ago. But for now, we need to give it a starting point to really understand what we're looking at. So let's do step 1, and then we'll get into the next ones. There is a step-by-step guide here, including a video to really take you through the configuration if you don't remember everything I say today. But the concept of this is really to identify down. It does sound silly as I say it out loud, but really understanding where would be the point if you're out on a mast arm where it's angled slightly different. How do we really understand the curvature of the lens, and how do we rationalize that with a zone on the ground? The purpose of that is to, one, also help us with zone drawings, so like it helps with the curvature of the zone, but it also gives us an idea of what is the overall curvature of the fisheye lens. And you can see how it's a 360 camera. We need to really rationalize what that means to a computer vision type device. And so this step gives us just a quick way to validate which way is down and what is the curvature of the camera. And you can see I'm basically dropping this dot in a way that I can line it up to vertical images. So I'll put that right about there, and you can see I'm kind of following that pole on the ground, assuming the poles around the intersection are also straight. We're somewhat aligned to this one across the street, and again across the street. So we're looking for those vertical lines just to really line up the position of where the center dot would go. And so it doesn't have to be perfect, but the better you do here, the better the following steps, or the easier the following steps are. So we'll hit continue. This step is about the height of the camera. If you know the exact height of the camera, just go ahead and type it in. You don't really have to play around with this tool too much, but this is really a way to help you estimate the height of the camera. So when we were talking about a computer vision algorithm, we're looking for an object that looks like a car, a truck, a bus, a bike, whatever it may be. But we have to give it a starting point. What is it looking for? What is it looking at? And this measurement tool gives us that starting point. So it's about the size of about a Honda Civic, I believe here, but you can size it accordingly. So call that roughly the same size. We're about this high, gives us that starting point and really gives us an idea of what we're looking at. The next step is about directionality. This is about labeling. So when I talked about movement to phase to detector zones, this is a crucial step to just help us with the labeling, to help us understand what directions we're looking at. And so if I spin around, you'll notice that the camera direction here under the image is actually changing. That's really for us to determine, are we looking in the right direction? And are we pointing where we need to be pointing? And so we want to match this image on Google Street View to the image on the right. We're just pulling in a Google tool here to help us with labeling, and it'll help us assign to movements as well. So that really helps us with that. I'll just put it to, we are looking, that way is north. This way is north, there we go. So camera configuration is now done. Now we can get right into our detector configurations. One thing to note on your first configuration, you'll get this little pop-up. There is currently a maximum of 5 views. So a view you can almost associate with an approach. And so what that means is you can configure each view to really do a number of things. And in a view, you can have as many detector zones as you want, but to a maximum of 5 approaches. The TMC configuration does count as one of those. So the thought there would be 4 approaches and 1 turning movement count would be in your video stream that we're looking at. So keep in mind how many approaches it supports today. We are expanding that capability in a couple months to go a little bit higher than that. But for now, we're at this point. So look out for that update in the future, and we'll expand that quite a bit. But that just means we have to consolidate to 4 approaches, which, I mean, this intersection has 4 approaches, so that makes it a little bit simpler. So to get started, we could just start clicking on the image. And so let's look at, which approach do we want to start with? Let's maybe the obvious one right in front of us. So when I clicked on that approach, you can see that immediately it's already labeled everything for me. That was because of that configuration step that we did before. This is the Clark Boulevard. It's showing us the direction we're also facing, and it's giving us a nice starting point of labeling. And if it's wrong, you can just change the label to whatever you want it to be, which makes it even easier. So we'll hit done. We got a direction. So now we can pan around. We can look at essentially what we're trying to configure, but we are focusing on this approach here. So at the bottom left, we can now start drawing either our detector zones for vehicles or our crosswalk zones. So I'll just click that button and it gives us a zone. And I'll just size it appropriately to the actual lane that we're talking about. And here we're looking for, I would just stay within the lane. You don't need to overcompensate for overlapping onto other lanes. You can put the zones right up next to each other. The way we do movement assignment is based on the center line of the zone from the center line of the car. So really understanding the projection of a car in the closest lane that it is what we're going for. And the more you overlap zones, the harder that reasoning is for the system to do. So keep them, try to limit overlapping, but if there's a special case where it makes sense, please let us know and we'll help you through it. You'll also notice the directionality of the zone. Enter in the green, exit from the red. The directionality is important for a lot of reasons. You don't want wrong way or the following, like the left turns from over here, coming across it and placing a call in your left turn zone, or you don't want wrong way drivers placing calls for whatever reason. But with that said, you could use this as a wrong way detector. You could flip the zone around and know when is somebody driving the wrong way in my roads here. And so you could get clever about some of the applications of it, but generally you're looking for the entrance to the exit of the zone. But since the zone is drawn so far, I do know there are cases where you say you have side driveways, like a gas station is a good example of that, where they're almost right up to the intersection. That's okay. The cars can enter from the side of the zone as long as they turn towards the exit of the zone. If they turn away from it, obviously it's headed in the wrong direction and we don't place a call based on the vehicle in that zone. But if it's heading towards the exit of the zone, then we'll place the call. So they can enter from the side. So try and think about the surrounding lanes while you're configuring, just to make sure that we're drawing them the most appropriate way possible, but they shouldn't have too much impact. Button there. All right, so we got the left turn zone here. And so in this step, we're actually just drawing the zones. We're not associating them with anything just yet. We're just drawing the zones. I'm going to draw another vehicle zone here. One thing you're probably wondering is, what does that signal ahead? Does that signal ahead in the field of view have an impact? The answer is no. This zone, this is such a small part of the frame, and we can identify the cars quite well, and we can see the vehicle enough even around this signal pole that it won't cause any impact or generally cause false detection. So it is something that on the odd time will happen where we'll get some blips out of it, but generally it's not a problem. And if it is, please let us know and we can address it. So this will happen. Not every deployment will be perfect because of various reasons, various signal designs, but generally it's not a problem. So if it happens, don't worry too much about it. Think about the intersection operation that you're looking for, and you don't have to black out any regions, or you don't have to add in any extra tricks here to get it to detect properly. It'll just reason that there's a vehicle and to place it in a zone and place a call to the intersection itself. And so you'll notice I drew the zone just past the stop bar. We know how right turners like to stay right at the stop bar, so compensating for them going across that stop bar a little bit is always helpful. Or if you do functions like delay, which we'll show in a second, can help manage that as well. So I'll just play around with this. You can probably spend all day playing with zones because it is pretty fun, but let's just draw right up to there. So now we got a through lane, a through right lane, and a left turn. Before we move on to the next step, let's quickly do that crosswalk zone. So this is about crosswalk counts, and you'll see because we're limited to the number of views from that previous statement, we have to draw the crosswalk zone at the same time as the vehicle zone. So here we're also including the crosswalk count with the actuation zones that we're doing for the intersection. So we'll stretch that right out, curb to curb, make sure we're maybe having a little bit of a buffer. The system does account for a buffer on its own, but pedestrians don't always follow the lines, and so helping them out a little bit, making sure we're including what we want in the data is always good. So now we have our left turn, our through movements, and our crosswalk zones drawn. So let's add function to these. Let's determine what do we do once a zone is placed. So we have this left turn. Let's start with this left turn zone. You can label it whichever you want to label it as. Let's say this is, I think this was the eastbound approach phase. We said odd numbers, so let's call this phase 3. This will also be our channel 19, because I don't know if you remember on the last page, we were on an offset of channels over to 17 through 32, which you can see down here. So channel assignment, again, being the important piece, this is just a label at the top, but down here we actually associate a channel to it. And so since this somewhat follows the same convention, just offset by 16, phase 3 is going to be our channel 19 in this case. But it could be phase 3 equals channel 3 or more. And so you can even toggle along the bottom of what channels are available to configure. And you can see it goes all the way up to 64, but the grayed out. That's because we only said use detector rack 2, which is our channels 17 through 32. So we line this up with our eastbound, maybe I'll say this is the eastbound left. I'll say this is a left turn. We have some modes here for, say if we're having, if we want to override some of the functionality for how we place detection calls, and this would be in obscure far distance movements, or we're having particular challenge with the way something looks. Hypersensitivity mode is around the ability to detect just on movement in the zone, not necessarily the full recognition of an object. We really only use this in a support scenario. So if we're having issues for some reason that isn't addressable in the general model, we can add a layer of sensitivity so that it detects a little bit more. It tends to introduce false positives, but if the problem is obscure enough, then maybe false positives are better than missing something. So it's only used in support scenarios, so if that comes up, please let us know. You can determine what the call is based on. So we only have 2 categories, or I guess 3 categories in this today, but really this is around, are we placing a call for all vehicles in the zone, just motorized vehicles, or just bicycles? So generally I say whoever is in this zone, place a call regardless of the type of vehicle. And so then we get all vehicles. We can decide, is this presence or pulse? We're really only talking about presence today. Presence is our actuation mode for the stop bar. Pulse would be for your count zones, so placing count data for approach volumes, or in some cases, if you can get enough upstream, you can do some upstream counts or in-zone counts. Often it's the limitation of the camera though, just the distance we can see if we're using this pulse zone. So generally, if we're using presence, we can then add a delay to it if we want, or we can extend it if we want. Most of the time, these functions are managed on the controller side, but you can do them in our product if you want to, and you can add a delay. This is often used on our right turns, the delay. So if you say, if a car is waiting to turn right in your right turn zone, you don't want to tell the controller someone is waiting unless they're there for too long, because generally the right turners just go, and you don't want to cycle the lights just because someone took a few seconds to get going. So anyways, that is an option there. So we'll hit done on this zone. We'll do our eastbound through right, phase 8, channel 24. So that's just, again, a label. We'll say it's a through right. We're saying presence, no delay and extend, and channel 24. These are the channels that you want to make sure you're associating on the controller side, making sure that when channel 24 is being placed, the controller is accepting that as phase 8. So we hit done there. We'll quickly just check our crosswalk. This is, since we're talking about eastbound, it is on the west side of the intersection, so we can just say done, and then we'll say done. So now we got one of the approaches set up, and you can see on the map it drew our nice little box, and then we did another one, so I'll just quickly add a second view just so you can see what that looks like. But we'll move on to the TMC configuration. I just won't do these perfectly right now because I'm just taking a look at the time there. So if we drew those zones on there, we'll just quickly skip through. This will be our 1, note down left, phase, we'll say 1, which may be, or no, that's already in use. So we'll say left. If you need to just quickly label these, so you can see I'm doing multiple lane here as well. So you can do multiple lane if you want to, and then just associate them on the controller side to the same phase, or you can just make it the entire approach. So both options are available to you. You just got to make sure you associate properly. So I'll just quickly do these ones just so you can see. Down 2, just so you can see what that looks like. And then we'll hit done. So you can see we got the first approach here and then the second approach down at the bottom. This allows you to just go in and edit them individually if you want to, or add to it, or change the view if you need to. So you work your way around the intersection, doing that as much as you need to for every movement and every channel association that you want. As soon as you're comfortable with those zones, you hit this little back arrow. The last step, step 3, is our turning movement count. This one is really straightforward, really easy one to configure. We drop the zone, the big box, so we'll spin this around so it matches our directions. The thing to keep in mind with the turning movement count is directionality. And so we'll size this appropriately and we'll get it to the right spot. So we have our eastbound, southbound, westbound, and northbound. You can see they highlight as I go over them too, which makes it a little bit helpful to recognize where you're looking in the image. I'll hit continue. We quickly want to line up where we expect in and outs to be. So this is for green again is in, red is out. And so we just go curb to curb essentially for these and adjust them for each one of our movements. Again, this helps with the accuracy of what we're expecting a vehicle track to look like. And it also gets us our count. So we're looking for the ins and outs around here. And then when I click next here, it automatically draws our movements. So it gives us the standard template to begin with, and then we can move our lanes around. We can put them where they're supposed to be. And again, like I said, with that heat map, you can adjust these after 24 hours afterwards to make sure that you got it in the right spot. And you essentially can move your way around adjusting the lines. To do eastbound, you can label each one of the movements if you want to. You can say, call them something specifically if you're using our API for whatever reason. You can label them in any way you want to, or if there's a specific convention that you follow, you can go ahead and label them. If say you needed to on one of the approaches here, so we have our right turns. If you needed to actually add one of those dual lanes, because I told you earlier that that's super important, you just adjust them as such. So I'll move that one over there, and then down here you can see a new movement. So let's add another through movement. So going through 2, create. It adds a second movement for us so that we can do a dual lane right there. And so that gives us the turning movement configuration. We just essentially work our way around each movement and we configure them as needed. And then if we're happy with how we drew that, we hit done. And so now you can see as we're going, the little image here on the left is actually building up. It's giving us each configuration we're doing and adding it to the video itself so that you can kind of rationalize how that looks like. Once you're fully happy with your configuration, you've got your right channel associations and all your movements are set up, you can hit the deploy button that actually sends it out to the device, or you can save it as a draft. Saving it as a draft would be used for, say you weren't quite sure about something or you needed to double check a channel or change your controller configuration. You can just simply save it as a draft and come back to it later. So that does bring us to the configuration that I did have there already. And so if say I just want to finish on that detector heat map configuration. So we did have this one up and running already for this session. I do have my edit draft up here in the top, so I can go back to what I was working on. Or I can go into this existing one and edit this existing one. So if I click on the right here, I can say edit. I'll go into the one that I already have set up. I'm going to click on the turning movement count side. Once you're here and this has been running for a certain amount of time, it does provide you the layers. So on the top left, there is a layer list where you can toggle through what you may want to look at. You can add labels, or you can just look at the track overlay and then adjust your lines based on the actual activity on the road. So this populates, like I said, 24 hours after it's been configured, and you can make adjustments as you need. And so you can see you can follow the lines, blue, and every color is more randomized. It's really just to give you an easier way to look at the image. So the color doesn't mean much other than it's just different than the others. and helps you keep track of what you're actually looking at, and you work through one approach at a time and make adjustments. Once you're done with that, you can keep remembering to deploy it back out to the intersection so you have the most current one running out there, and then you can iterate from there. I do know that time of the year is important, so one thing that we do at Miovision is we keep track of how does it perform in different seasons on the detector actuation. How is the turning movement counts performing? Do we need to make adjustments to the zones or the lines or the tracks, and keep iterating on it? That's one of the best parts about having a remote configurable device. And so if you're happy with everything and you've deployed it out, we can jump over to the video. So on the side left here, there's a video icon called video. We click there first. This gives us that live stream so we can see an intersection. We can see while it's operating. One of the other recent features that we launched is the pan, rotate, and zoom. So you can actually click on the little icon here at the bottom and you can rotate around, you can zoom in, do whatever you need to on the live view. So you can do situational observations, or you can then flip over to our detection view and watch it in action. So last point, and then I'll look for questions and I'll wrap it up here. And then we can see everything deployed. We can see our zones and our counts. So great, everything is up and running and we have a fully functioning intersection. And that's how you validate. You can iterate, watch how cars are actually interacting with it. You can see as a car enters the zone, the box goes green. All right, so I'm gonna start wrapping it up and then hand it over for some questions. Right before I do that, I'll just go into present mode here again. Training like this, there's a lot of content, and I kind of recognize that there's a lot of information I kind of ran through there about configuration. So I'm kind of curious, what type of training resources do you find the most useful? Is it knowledge articles? Is it video tutorials, in-app walkthroughs, webinars? Like what is the best way to digest this information? And Shannon will open up the poll there to get some answers to that, and that will help us tailor our training to the group in the best way possible. So I'll leave that for a second, and then maybe Shannon can let us know how that went.
You bet. The answers or responses are still coming in. I'll give it a few more seconds. All right, I will close it out here and share. Not surprisingly, our visual tutorials and in-app walkthroughs scored high with 42 and 34%, webinars at 19, and knowledge articles about 5%. Brent.
Oh, okay, great. That's good to know. We have some training and support available that I'll point to, and then I'll open it up for some questions. So to kind of that poll question, which is great to hear that we're kind of on the right track with some of our information. We do have our knowledge base articles available, although scored lower. They are available with everything that we do collect in our knowledge base at the Help Center. We also have our video tutorials online at training.miovision.com, which is a great resource to kind of cover a lot of the topics I just went through. So that will be available to you as well. Just to, I guess, wrap it up with a final message here, and then I'll just see if anyone wants to hang around for some questions. So that was our session for detection and counts today. Obviously, a lot of content that was covered, a lot of things on specifically operating the intersection and getting into the configuration. So we're happy to dive into that with individuals or more after this, but we do have another session coming up, so please feel free to join us at the next one around traffic signal networks with TrafficLink, so remotely managing your signal network. We're going to cover things around managing users, alerts, working with live and historical telemetry, managing video, communication architecture, and some remote access. So feel free to join that and listen in. As you sign up for them, you will get some registration emails coming from us, as well as a email about the on-demand clear signal session. So you can attend one of these and work through the clear signal side, which is around the performance measures on your own. So that's an on-demand session you can do well on your own. So feel free to tackle that one and let us know how it goes. But yeah, so we're at the top of the hour here, so I tried to get through quite a bit. Probably didn't cover everything, so I'll hang around for a few more minutes and see if there's any questions in the chat. Maybe Shannon, you want to check out the chat for me, and then if anybody else wants to post some questions following this, feel free to reach out to us. Any
yeah, we just have a couple minutes. No, none that I can see. So if anyone has any questions, if you don't know that there's a chat section to the right, you can go ahead and add your questions there. If there are any questions, we may also be able to take you might be able to unmute your microphone and chat with us if you just wanted to ask the question directly to the group. Oh, actually, I see a few coming in. What is the range of the camera? How far away from the camera? Sorry, this is giving me a little bit of troubles reading this. What is the range of the camera? How far away from the camera to the back of the given zone for, let's say, 30 feet camera mounting? Sorry, okay, guys.
I get the question, I think.
Okay.
So thinking about the height of the camera, obviously it sounds like you understand the table a little bit there of height versus distance. Generally at 30 feet high, the camera can get you a front of the stop bar zone at 150 feet, stretching back to about 190 feet. So it gets you a nice 40-foot range there to play with. So the back of the zone looking at around 190 feet. So hopefully that answers the question.
Yeah, another one here. What is the difference between actuation and presence detection? Is Miovision able to collect actuation as well?
Yep, very much the same. To us, it means the same thing and somewhat use them interchangeably. An actuation would be the controller actually actuating, so placing a call to actuate the intersection to cycle it. We often use presence detectors to cause an actuation. So the phrasing is somewhat, I guess it means the same thing in the sense of a presence detector is placing for actuation. And so we are collecting, and main purpose of this is for actuation. So hopefully I answered that question well enough.
We'll take one more, and then I do see other questions have come in here, so we'll be sure to respond offline, but I know that we're just a couple minutes over 2 o'clock, so we'll wrap up with this last one. Are there advantages in Miovision using one large zone that covers multiple lanes under the same signal phase versus individual zones per lane?
It's a good question. I actually get asked that question quite a bit. To us, it doesn't necessarily matter. Often when I do lane-based, it's because we have a lot of detector channel options. We can use all the channels, so why not use all of the channels? But for simplicity, you could just do one zone for an entire approach, and then you really only have to worry about one channel to one phase instead of like 3 to 4 channels to one phase. And so it's just the appetite for complexity or specific intersection operations. But to us, there's no difference in benefit necessarily. Sometimes when you're stretching the distance a little bit of the camera, where maybe your camera is a little bit too low than it should be, and you're stretching the distance a little bit, sometimes doing one zone over multiple zones does help improve accuracy of detection if you're kind of on the edge or you're a little bit past the edge of the distance it can see. Simplifying the zone structure helps quite a bit. But if you're within normal ranges of the camera based on height, it doesn't really matter to us, or there's no benefit one way or the other. Cool. Was there a lot of other questions in there, Shannon?
There are. So do we want to, we can follow up with everyone afterwards?
Yeah, I think that that's a good idea. So I can take a look at all the questions afterwards and maybe reach out and maybe we can have some little side sessions about getting into some further information, because I do recognize there's quite a bit of information here, and sometimes a good little session afterwards helps. So I'll look through the list and I'll follow up following this.
Great. Well, we thank everyone for their time today. And we'll be sending out a recording of this shortly after in the next day or so.
Great.
Thanks so
Sounds
much,
good.
Brent.
Thank you so much, everyone, for listening, and feel free to reach out if there's any further questions, and I will be sure to look through that list as well. So thank you so much, and have a good rest of your day.